questions. We'll quickly go through these. Which of the following describes electrical conductors? They have valence electrons, loosely bound, so that's going to be B, this one here. A typical use for aluminium. Aluminium's nice and light, so where do we use it a lot? Those transmission cables. When you go alongside the motorway, you look up at those big power cables, they'll be aluminium because it's nice and light. Can keep those towers further apart. Cable's cross-sectional area is increased. So what's going on here is they're saying we've got a cable like this, and they've increased it so the same length, but they've made it fatter. Okay, they've increased the CSA, so it's a thicker cable. What will happen to its resistance? This is going to be a lot better at carrying current, so its resistance is going to go down. So its resistance will go down. It will decrease. Its resistance is going to decrease. 100-meter cable. Let's draw this one. I always like to draw things. I can see it then. Okay, 100-meter cable. Let's draw then. Here it is here. It's 100 meters long. It's a fairly long cable. Okay. And you've done an insulation test and you've got 200 mega ohms. So you've gone from there to maybe ground, and you've measured 200 mega ohms. That's good. It's a pass. Okay, what will if the cable was shortened to 50 meters? So if it was half as long, get rid of that bit. Now it's only 50 meters. My insulation will actually go up. Okay, my insulation is shorter the cable, the better insulation resistance I get. As my cable gets longer, my insulation resistance decreases. So I've gone half, so this is going to double. It's going to be 400. Pure DC circuit, Ohm's law. Ohm's law. Let's draw Ohm's law. Ohm's law. What's that one? Ohm's law. This one here. V equals I times R. Or we can draw it as a triangle A. V equals I times R. Okay, current and resistance. If I take that up, that goes down. It has to for my V to stay the same. Or that one and that one. Inversely proportional. So I'm looking for inversely proportional current resistance. Current voltage, no. Inversely proportional voltage. Proportional current is inversely proportional to the resistance. That's the one I want. 3 kilowatt heater is used for 6 hours. 3 kilowatt and unit, so 3 kilowatts times 6 hours equals 18 kilowatt hours. 25 cents for each kilowatt hour, which is $0.25, 25 cents. 18 of them times 25, we'll give you $4.50. Okay, relate to the diagram below. What is the total resistance of the circuit? Total resistance, we don't know there's resistor, but we know current A. R equals V over I. R equals V over I, which equals 30 volts, divided by half an amp. 30 times a half divided by half will equal 60 ohms. Have we got a 60 ohms? Yeah, I hope so. Okay, let's have a look. 60 ohms, yeah, look at that. Okay, next question. Total resistance of the parallel branch R2 and R3. Let's go up and have a look at this. These two are in parallel. So it's 1 over 30 plus 1 over 20 inversed, or what I do, if it was two 20s, it would equal 10. If it was two 30s, it would equal 15. So I'm looking for an answer between 10 and 15. I'm not even going to get my calculator out. I'm going to see if there's an answer between 10 and 15. And there is. That's a bit of a cheating way of doing it, but it works. Okay, 12 ohms. Resistance of R1 would be, so if that one there is 12, if this is 12, that's 30. That gives me a total of 42. And we said the total was 60, so 42 here. Let's draw that in. Got 30 there. This one here is 12. 30 plus 12 is 42. This one here has to be, because we said the total resistance was 60. This one has to be 42. This one has to be 18. Alright, let's go down and have a look. I've got an 18 there. I got an 18, I know I'm right. Okay, 18, nice. Total power dissipated by the circuit would be P equals I times V. Is that right? I times V. Half times 30 is 15. There it is there, 15. A cell that can be recharged once it has been discharged, so if it's a rechargeable battery, is what we call a secondary. Capacity measured in watt. So it's how many amps hours. So it's amp hours, not amps per hour, it's amps times hours. So it's amp hours. Okay? Not amps per hour. Which of the following could be used to reduce corrosion? Protective coatings, yep, paint it. Alloying, definitely. Neutralizing the environment, so it's all of the above. Device which consists of electromagnetic that when an EMF is applied to the coil attracts electrical contacts. That switch, it states, best describes us. This describes those contactors we're using to control our motors and also relays, okay? So contactors and relays. Relays are a smaller version of a contact. So that one there is going to be the relay. Frequency. What does frequency mean? It just means how many times something happens a second. So let's see if we've got that. Time's a key. Time taken for one cycle? Nah. Number of cycles per second. That's what we want. Number of cycles per second. RMS value of a sine wave having a maximum value of, I like to draw these and you can see them. Got a sine wave. I'll get a bit of colour than that. Right there. Okay, got a sine wave. There's my sine wave. Maximum value of 325. My RMS is around here somewhere, 0.707. So I'm looking for a number less than 325. So that rules out that one. And it's not half, it's more than half's down here, so that rules out that one. And it's not 325, so it rules out that one. So I know it's this without even doing any maths. But if I want to do the maths, I go 325 times 0.707. How do you remember that number? Lol. Laugh out loud. Turn it upside down. That's how you're going to remember that. .1. What is the unit of resistance? That's too easy. Okay, lead acid in the cell is a form of. Okay, so lead acid is what we have in our cars and that, and we can recharge them. So if it's rechargeable, it's a secondary cell. In terms of cells and batteries, a primary cell cannot be charged. A device that uses two similar metals to produce an EMF from a heat. Okay, so you get two similar metals, you join them together, put them in heat, and electrons will travel from one to the other, and that is a thermocouple. Which of the following methods produce the most EMF in New Zealand? What do? We use hydro, which is magnetic generators. We use hydro and wind, mainly hydro. Let's finish this here, it's getting a bit long.